Hello everyone, welcome to our video. In this video, we're going to talk about the finite difference technique for seepage analysis using Microsoft Excel. This is the problem we're going to deal with. We have a seep pile of which is supporting 6 meters of water. As you can see here, it is 6 meters of water, and it has a concrete slab, which is we have a concrete slab over here, which is practically impermeable. So we're going to treat these as impermeable layer, which is on downstream. This is our upstream, this is our downstream side, as shown in the figure. For the sand, the horizontal permeability Ks equals to 0.09 and vertical permeability is 0.01. We have the void ratio, etc. I don't think we're going to use this one for this lecture series. For right now, we're just going to focus on the calculation of drawing the flow net, and we could determine the flow rate as well, but right now mostly we're going to focus on the finite difference technique for the seepage analysis using Microsoft Excel. So we have a bit of a theory as well, we can focus on that, but let me just give you a brief history regarding the seepage analysis. So I have a case scenario, a bit different question, but this is how normally we have been drawing the flow diagrams. This is how we have been drawing the flow nets, and this is how we have been drawing our equipotential line. So we have a seed pile over here, and what we basically do is just from the higher head to the lower head, we just draw whatever the lines, whatever uh, type of the line we need. So what we have here is this is our seed pile. So this is my seed pile going on over here. This is my seed pile. Sorry, not with a straight line, but so we have a seed pile going on over here. So this is my upstream side, or you can say this is my higher head side. This is my higher head side, and this is my lower head side. And in order to draw the flow lines, what I basically do is I just follow the path from the higher head to the lower head. And of course, it's not going to be a random line. We need to draw some circles. The circle needs to be decreasing, and there are many rules, but maybe for next video. This is I'm just trying to explain how we have been normally drawing the flow lines, but this time on the finite difference technique, it is a bit different, maybe a bit complex, but we will try to make it as simple as possible. So what we're going to do is we are going to use a simple circular reference in a spreadsheet. So what we're going to have is we're going to focus on this sheet. Okay, this is the sheet, and we're going to focus on this cell, and this cell. So basically we have four different type of cell. Okay, this is going to be my cell which I'm going to focus on, and the value of this cell depends on this and this. The value of my cell depends on the four different type of the depends on the four different cells around it. Okay, so let me just this part. Okay, we need to focus on this part, and okay, just let's focus on this part of this part. So we have okay, this part. So I need to focus on this cell. The value of cell will depend on its neighboring four cells. So if this is the set, if I need the value of the set, if I write it as h naught, it will be h1 plus h2 plus h3 plus h4 divided by 4. So in the Excel, what we're going to basically do is we are going to have a delta del x and delta del z. In the x-axis x and in the y-axis z. So x-axis represents for this x-axis is going to represent this is going to represent delta x, and this is going to represent delta z. No, not just this part up to here. Overall is going to be my delta z. So this is my x and this is my z. Just explained before h naught. So the value of h naught, this cell h naught is going to be h1 uh, h1 plus h2. So this is my h naught, and this value will be dependent on the four cells h1 plus h2 plus h3 plus h4 divided by 4. So as you can see over here, this is the formula we are going to base on output in our Excel file. So our Excel is going to look something like this for this sheet file. So we're going to jump on into Excel as well, and we can see it bit on clearly. But this is how this is my sheet file. So as you can see here, this is going to be my sheet file. This is going to be my head value in the upstream side. This is going to be my head value in the downstream side. Okay, just bring it down so we can have a little bit overview of the Excel. Then I can we can jump into the Excel and we can see the formula as well. As you can see over here, this is my sand layer, this impervious layer in the bottom, and in the up we have the water of 6 meter over here. The total head is going to be 6 meter plus the elevation head. The elevation head HE equals to 8 meter plus 6 meter, which is going to be 14 meter. So the head we are going to have over here in the top of the concrete slab is going to be 14 meter. So as I explained before, in the this we are going to deal with delta z, while in this section we are going to deal with delta x. Okay, so we have on this point we are going to have extra head because of the water above it, which is going to be the elevation head, which is 8 plus 6. We have 8 plus 6 is 14. 14 plus 6 is going to be 20 meter. Okay. So these are the first step. Step 1 is we are going to have the find the total head, and we are going to put all the value of the head in the appropriate section. Of course, there is going to be okay, this is not the step 1. Actually, we can say this as step 2. Step 1 is a bit different, but let me focus a bit on how the formula works. So as I explained before, the each cell value in the Excel is going to be depend on its neighboring cell. We are going to determine this cell value depending on the neighboring values. So we have the formula S naught equals to, it is basically the average of all its neighboring cell values. So we have this formula. So it is basically done by some derivative. We have some derivative. We normally set delta x and delta z to be equal, and on solving that we basically get this equation. You can see this on your own, but it is not what we mostly focus on right now. This is not, not going to be focusing much on this video, but okay, you can see that as well if it is of use to you in this section. So we have kept it over here, but if it's not use of you, we can just jump directly into the main part, which is how to draw this Excel and how to draw the flow net and the equipotential line using Excel. So one of the major limitation of how we were doing this was we were just drawing the random lines. Of course, we had some knowledge regarding how to draw this, some rules, some thumb rules, but the main issue was we don't know the head value. But as you can see, when we are going to use the Excel for each point, for each elevation, so this is going to be, so this represents my elevation. Okay, so let me just draw it over here. This represents my elevation delta z, and in the x-axis we are going to, this is going to represent my delta x. So the so what basically happens here is we can know the value of the head, and we can know the exact path what the water will flow. So I've highlighted a cell over here. So this cell value is definitely is going to be the sum of this surrounding cell. Okay, so this is my going to be my H0, and this is my H1, this is my H2, and this is my H3, and this is my H4. So basically H0 is going to be H1 plus H2 plus H3 plus H4 divided by 4. But we cannot jump directly into this formula. Firstly, we have to determine, firstly we have to set some boundary conditions. We have to set our x and z axis. We have to draw a bit of the seed pile and stuff. So basically I will explain you what to do. So this is my question, and this is how my Excel will file will look like for this seed pile case scenario. So it is a bit uh, messy around it. Let me just clear this up and I'll explain how this seed pile is drawn into the Excel file. So firstly, we have to determine our delta x and delta z. So we basically set We basically set delta x and delta z to be equal. So right now we need to focus on this part. Okay, so we have our sheet pile going on over here. The length of our sheet pile is going to be 8 meter and the total depth is going to be 14 meters. So this is are going to be the main clue for determining the delta z. Okay, so in order to determine the delta z, what we can do is right now we are taken from 0. So you can take any depth as you want. It's 614. So right now we are taking this level of the impervious layer. So right now, okay, in here this is going to be my 0 meter or 0 coordinate. So we need to go up here. So this is going to be 14 and this part is going to be 6. So simple mathematics, simple coordinate system. So we have put 0 at the bottom and we go 1 2 3 4 5 like this, and this is going to be my 6. This is going to be my where the sit pile depth exists, and we are going to go up till 14, and this is going to be my water level. This is where my water level, no, actually the water level is a bit higher, but we don't need to draw this portion in the sheet. We are going to deal only this layer, this part. So we have just plotted that down over here. So as I explained before, we need to put the head value firstly. So as I said, we need to put, sorry, erase this again. We need to put the head value. So regarding the x-axis, we can take as much as we want, but basically we just take twice the value of the depth. So if we are for Excel analysis, just for our assumption, but for in Excel, for better calculation, we just take, okay, so if this is like 14, we are going to take this x-axis normally as 28, but it's upon we can take around 20 as well. Okay, so we don't have much criteria on that, but let me jump now directly into the Excel and show how the calculation is being done. Okay, so this is my Excel sheet. This is how my Excel sheet looks. uh, Let me just grab the question as well, so we can copy the question and let me just paste it over here. Okay, so this is my question, right? As you can see over here, we have our question over here, and this is 6 meter as I have explained before. 6 meter. So this is going to be 6 meter, and this is going to be just grab pen. This is going to be 6 meter. I don't know why. Okay, so this is the question we are dealing with, and okay, let me just grab my pen. So this is the 6 meter over here. We have 6 meter over here, and total we have 14 meter. So on the upstream side, the total head is going to be 14. 8 plus 6 14, 14 plus 6 20, and in this side the head is going to be just 14 plus 6, which is 20, because this is just the elevation head. There is no water head on the downstream because there is no water, but there is going to be potential head as well on the upstream side. So basically we just put this value 20 20 20 20 20 20 20 20 20 on the upstream side, and on the downstream side we are going to place 14. But we have an impermeable concrete layer which is equivalent to 1 2 3 4 5 6 meter, I think. This is going to be the x value is given us as 6 meter. Okay, so this is going to be 1 2 3 4 5 6. But okay, let me just explain regarding the boundary conditions at first. So firstly, as I told you, the x-axis we have taken 0 for this part. The impervious layer, this is going to be taken as 0. Then we'll go 1, 2, 3, 4. So this not too much complex, just basics. So okay, this is how displaying the screen. Okay, okay, let me explain. So I have taken uh, this part. Okay, so I have taken the bottommost part as the 6 meter. So this part is going to be my 0 meter, and this is what I am dealing with. Okay, so this is basically the uh, what I am dealing with, and Now I just set this at 0 meter, 1 2 3 4 and 14. Okay, this is how we go. And in the x-axis right now I am choosing 24. So as I explained before, we have taken the depth as 14. So 14 into 2, 28. So we can take the x-axis up to 28, but right now I'm just taking it up to 25, and we need to put 0 right in the middle of the sit pile. Okay, so this is going to be 0. I've taken 0 on both sides, and I need to go on for the x, I need to go till 24 on one side, and I need to go till 24 on the other side as well. So hopefully you have just gotten a good idea of what the question is. We have depth of 14, a water head of 6, and regarding the x-axis, it's up to us what do we want to take. And regarding this impermeable layer, we have the boundary condition as up and down, both are impermeable layer. Next we have the value of x, this is going to be 6 meter. And now where we have a different kx and ky as well, so I'll focus on that a bit later. So now let me just explain how this excel file is going to work for us. So just put this bit down. So the x-axis, it depends on you, you can take till 30, 32, whatever you want, but make sure that on the left side and right side you have taken equal values. Okay, so now for the y-axis or the z-axis, you need to make sure you match the exact condition as per your question. So right now we have 6 meter of pile depth, so we have taken 1 2 3 4 5 6 six, sorry, 6 1 2 3 4 5 6. So from 6 meter, as you can see, the depth of the seed pile inside the sand layer is 8 meters. So this needs to be 1 2 3 4 5 6 7 8 8 cells. So 1 2 3 4 5 6 7 8. Each cell is going to represent 1 meter. Same at this side. And next we have so this is basically 0, right? Okay, so this is 0. We are starting from 0 coordinate. What you can do is you can just put 0 in the middle and you can do 1, but I found this way to be more easier. So you can just put so the length of this impermeable layer at the top is 6 meter 1. So we are beginning, since we are beginning from 0 coordinates, so going to 0 1 2 3 4 5 6. This is going to be 6 meter, so this is how it's represented. And we put 14 14 14 14 14 at the top of the head. So firstly, before beginning of the excel, before putting any formulas, what you need to do is set the boundary condition, set the limit of your x and z. So that, as I said before, you need to set the limit of the z as per your question, as per your question criteria. So this blue line represents the seed pile for me over here. Next, if we have an extra condition like this impermeable layer, set the condition as like that. So there is going to be no head value in this, but in here, so this blue and this I don't know, reddish type of line, reddish pinkish line represents this layer. So hopefully you have understood. This is the most important part. Next is just putting on some excel values and just going on. Okay, so after you have done this, now this is the part where the formula will come upon. So what is the formula I'm talking about? This formula, this is this h naught equals to h1 plus h2 plus h3 plus h4. So basically what we are going to do is uh, h naught equals to h1 plus h2 plus h3 plus h4. Okay, so we're going to write this is how my sorry, h1 plus h2 plus h3 plus h4 divided by 4. So this is the main formula we're going to put into the excel. Okay, but before putting on this formula, what we need to do is just look at. So we have completed this cell, right? Hope you have understood. So just we are putting on the boundary condition and this as well. Done. Easy, really easy. Next, after completing this, what we are going to do is we are going to focus on okay, you can just drag my excel down. After that, what we're going to do is we are going to focus on this part now. Okay, let me just drag my screen a bit down. Okay, let me draw it again. Firstly, we completed this part, right? Then we completed this part. Then we know this is an important behavior layer, so we completed sorry, this part as well. Next we'll be dealing on this part. So what is this? This is also going to be like my boundary condition. We're going to use the same formula as okay, let me just focus on this formula because this is the formula which is going to be everything for us. H naught equals to h1 plus h2 plus h3 plus h4 divided by 4. Okay, now you put your attention into this cell. Okay, so this cell value is going to be depend on this cell, sorry, uh, this cell and this cell, but at this there is no any value of the head, so it's an imperturbable variable. So instead of this cell we are going to bounce back again to this cell. Okay, hope you have understood this because this is really important. We're going to focus on this cell value, this cell value, and this cell value. 1 2 3 4. Okay, I think a bit confusing, let me explain again. So what basically happens over here is for this cell value is going to be depends on its four boundary cells, 1 2 3, but there is no any boundary condition over here. This is outside the layer, it's not the point of our focus. So instead of this we are going to have like a mirror thing going on. What we're going to do is we're going to focus on, instead of this cell we're going to focus back on this cell. Okay, so as you can see for the formula, okay, let me just delete this. I'm going to explain how we are going to enter the formula. Firstly we are going to put equals to sign, right? Equals to, just put on bracket, and you can use your keyboard, the up down left section or whatever you like. So this is going to be sum of this up cell plus h naught equals to h1. This is my h1, this is going to be my h2 plus, or you can just put any h1. Next is going to be h naught plus h1 plus h2 plus h3. This is going to be my side plus. Next is going to be my h4, or the last cell, which is going to be this cell, but we cannot focus on this cell because this cell is outside of my point of reference. So we are going to bounce back to this cell, to the right cell. So we're going to put this, divide by 4. This time we are going to use 2 times the value of this set. So it goes on all for this. We're just going to put the same value, put it like this. Just put the same value on and on. And when we move to this section, there is going to be one more interesting case, because in this we could not focus on this cell value, and on this we can only focus on these two cell values, because we cannot focus on this cell out of our reference, and this cell as well is nothing, this is outside our boundary condition. This is just for our reference of the z-axis. So this is the boundary where we are dealing with. So for this we are going to focus on this value and this value, and now since there is no this value, it's going to bounce back to this value, and since there is no this value, it's going to bounce back to this value. So basically it's going to be something like this plus this plus this, again add this, and again add this. So formula basically works like this. It's going to be p22, so this is going to be p22 plus q23, again plus p22, again plus q23 divided by 4, or you can it's just 2 p22 plus 2 q23 divided by 4, or you can just put p22 plus q23 divided by 2. It's just up to you, just average of the surrounding cell values. Basically you have got my point, and we continue the same pattern up to here, dun, 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 like this, right? And for this also the same case like this, we can go to this value, so the value gets reflected up to this point. Same logic, hopefully you have understood it. After that we are going to focus on this cell. Okay, this cell is going to be a bit different. uh, so as explained before, we are going to, for this cell value we are going to depend on this cell and the below cell, but on the right we cannot focus on this cell because we have a seed pile in between. It divides our boundary. Okay, it divides our boundary. So for this cell we need to bounce back onto this cell value. So for this cell we are just taking average of this cell, this cell, this cell, again bounces back to 19.8 value. So you might be a bit confused, like, oh, where is this 98.8 value coming from? Okay, So how this will actually work is I'll show you that also. For this also we just have to do this. Okay, but for this cell what basically happens is we don't have any value above here, again import variable here, so we need to focus on this cell and this cell, again this and this, same as the boundary condition we were dealing with here. Again just two cell value, just divide that. You need to be really careful with choosing the formula. So firstly put this values and focus on this boundary condition, the green lines and this lines, and focus on this area. Next is really easy, like for this we're just going to take the average of the surrounding four cells. Okay, so this just take the average of the surrounding four cells. Really easy, really easy. Just do on that, do on that, really easy, right? Really easy, it's the same. Okay, let me just create a duplicate of this, move or copy. Let me create a copy. uh, so in reality it might be a bit different, because when you are dealing with this, what basically happens is let me just focus on one cell. Let me clear the contents. So this is how it begins. There are going to be all the empty cells, right? There are going to be no any cells. So without the cell also we have to put formula like this. So I'm just going to use my keyboard. Just press the up button of your keyboard, 20 plus, just move down plus, then go to the right cell plus. Now what I need to do is I need to go technically to the left, but there are, since no any boundary on the left, I go back to right. Close your, divided by 4, done. Right, so this is how it happens. Just then pull this up to here, but since there are no any values on this side, okay, the cell is not updated. Next what you need to do is you can enter the value for this, plus just use your keyboard, nothing else, just down plus, go to the cell, go to the right plus, 10 10 10 10, go to the left plus, divided by 4. Easy, right? Easy. Just do this and just pull this up to here, and after you have done completing of this, just sorry, just do this and put it up to here. Really easy. So the value gets updated like that, and you need to run your iterations. It's a really simple thing. You just have to do it for all the cells. Just put the formula and keep on going on. So now in the x-axis what I have done is I have kept these formulas right now. So this is basically how it is done. So you just have a basic overview of how we have plotted all this. So it just goes on, just keep on doing it. If you have any confusion, just you can reach me out through my Instagram, email. Just put the comment down below on the YouTube. I'll just help you out, guys. So you just have to put the formula, but you need to be really careful of your boundary conditions, right? You need to be careful, like okay, I cannot go this side, or and in this side also, okay, I have to uh, you can choose this value a and 10 for this cell, but for this cell you have to bounce back to this value. You just do it with all the formulas and you're almost basically done with the finite analysis for your seepage. Next what you need to do is we need to focus on this cell now. What we have done is basically we have kept these values as minus 24. As I said, this is going to be my z value, right? And next I have something, and I have put this formula over here, which is dollar I dollar 27. Okay, let me check what is on dollar I dollar 27. Okay, so this is where your kx and ky comes into the role, since the kx and ky value. So if you remember, I don't know if you remember it or not, but for this case kx and ky are not equal, which means the flow in the x direction and y direction are not going to be equal. So if in this case the kx and ky was equal, you are basically done. Next you will just draw your flow lines, your equipotential lines, and you will be done. So okay, so we have two cases, kx equals to ky and kx doesn't belong to ky. So we are dealing with the case where kx and ky are not equal. Okay, so what we do next is just I'm just put on already all the formula over here. So the ratio of kx and ky is 9. The square root of kx and ky is 3, and root over. So basically what we need is we have a formula. Let me write down the formula. The formula is like this: x dash equals to x times root over ky divided by Ax. This is the formula we are going to deal on. The new x dash value is going to be x times, this is my x value, okay, this is my x value, x times root over ky by, this is my ideal 27, which is root over ky divided by kx. Ky by kx is 1 by 3, something like that. I get the value 0.3. So basically I have to value multiply all the x value with this value to get this value. So the logic behind this is we want to create the exact flow lines, but since kx and ky are not equal, we have to do a little bit of some corrections. So the next step, so what is going to be the next step is basically after this what we're going to do is we're going to uh, draw some flow lines and equipotential lines to see how the water will flow in between this layer. But what we are going to do next is we're going to do something called transformation. This is going to be my end result, okay, but what I'm going to do is I'm going to, okay, it's going to be my end result. So okay, but let me, before that I'll tell you what we're going to do. So basically we just put this value, right? It's going to be really simple. What you're going to do is we're going to select the cells from this cell. This is going to be our point of focus. Just remove, or not remove, sorry, the word is hide. We are going to use the function hide to hide these cells. Just hide the cells with the point values and just focus on the integer values. Just do this, hide. And for this as well, 6.7 and 6.3, do not remove, use the function hide. Just do this, just do this and hide. So doing this, we're going to get the actual flow lines, we're going to get the actual conditions since kx and ky are not required. This is before the transformation, how my cell looks like, and just keep on doing that for all the cells and we're going to get something like this. Okay, so I just have the integer integer value. Oh, sorry, this is not the one. I think this is one. After transformation is going to look something like this, but there is something wrong with this Excel file, but this is the one. So for this I have used bit higher values up to -42. We are using -24. So as I said before, depends upon you how much you want to use, and this is how my final Excel file final transformation will look like. After that we just draw equipotential lines and we're done, basically done. This is how we will determine the flow lines and equipotential lines. We just draw these lines. So let me tell you how to draw these lines. Okay, so firstly what we're going to draw is we're going to draw equipotential lines, and then we're going to draw our flow lines as well. So equipotential lines, what does equipotential line mean? Equipotential line means those we have the equal head, so we're going to basically follow the equal head. So we have somewhere like 19.4, 19.6 is going to be somewhere like 19.5. Just follow the 19.5 like this, 19.5, 19.5, just keep on following it. This is going to be my first equipotential line. Similarly, next is 19, just follow it, follow it, follow it, follow it. Next is 18.5, just follow it, and you basically get all your equipotential lines like this. After you get your equipotential lines, next what you're going to do is just draw your equipotential lines. What you can do is going to insert, go into shapes, where is shapes, just choose the curve and just choose n lines like 19.5, just follow 19.5. Okay, what you can do is, let me remove this line. Okay, just move it, just go into shape. It needs a bit of a practice, but just follow the 19.4, 19.6, 19.5, 19.5, 19.5, something like this, 19.5, 19.5, and like this kind of. Just follow the lines and you have drawn your equipotential line. After equipotential line have been drawn, just draw all the equipotential lines like this using your shape function. Next, what we're going to do is we're going to draw the flow line. The flow lines are basically perpendicular. They are just perpendicular to your that's perpendicular to your equipotential lines. Just go like this. Just try to make it perpendicular like this. Just try to make it perpendicular and just make a little twist and turns. Just try to make it perpendicular and you can just draw it. Okay, when you want to focus much on this part. So this is how basically you can draw your equipotential line and flow lines. But the main advantage we are doing is FEM is, just look at any point. Like if I want the value of the head, at like 12 meters and like some x-axis value whatever you want, you just get the exact value like, oh, 19.6 meters or 19.8 meters or whatever. So this is how we basically work. And you can find the value of q as well. The value, we have kx, we have ky, and now just find nf and any number of nf and n. So nf is actually 3. Okay. So and for nf, just count 1, 2, 3, 4. It's actually 4. There's a mistake. It's 4. Just count 1, 2, 3, 4. 1, 2, 3, 4. And any, we're just going to count these boxes: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? 12. Just put it. We have k, h, and the value of, just put the q formula. Q equals to sorry, this is my q formula. So q is basically going to be h hb22 is k into h into root over ky by k, sorry, q equals to kh root over an e by nf. Hopefully I'm not sure about the formula. bb20 bb20 is, yeah, nf, sorry. Okay, the formula is q equals to, I'm not sure, but maybe double check. I just have put in the Excel. So q equals to kh root over nf by n. I think this is the formula. I'm not sure. Let me check. So q equals to b22 bb22 k. Sorry, okay, k h, and we're just taking bb20. bb20 is ne. Sorry, it's ne or nf? Sorry, nf. It is nf divided by ne. So hopefully you have understood how we can use FEM. A bit long video, but hopefully you have understood. And if you need this Excel file, you can reach me out through my email, or just comment down below somehow. I think you can connect, or maybe I'll add a drive link below where I will upload this Excel file. So hope you have understood the video, and if the video was of help to you, do like the video, do comment like, oh, good video or something, and do subscribe to the channel. Thank you for watching the video.